Hello student, today I am going to find the solution of the heat equation in the condition where the uh, end temperature is non-zero. Okay, so the ends are non-homogeneous simply. So you can see, let's say this is the rod. Okay, this is a rod and the temperature at this point A and B. Okay, so initially the temperature are 30 and 30 degrees centigrade and 100 C. Okay, and after reaching in the steady state, the temperature will be 20 degrees centigrade and 40 degrees centigrade. Okay, so let us consider the heat equation. The heat equation ut equal to the general form c square u xx. So firstly we have to find the initial temperature distribution u. Okay, so you can say the step 1 or star this. The initial temperature distribution is given by, because the system is reaching into steady state, and before the steady state the temperature was these. Okay, so the initial temperature distribution is given by this u x equal to 0 with the condition the temperature at end A is 30 and B is 40. Okay, so you can say like 0 comma t equal to 30 and u 10 comma t equal to 100. So it is clear this is the second order differential equation. You can integrate twice and you will get ux only. This is the function of x only. So it is ax plus b. This is the general form. Okay, and by applying these conditions, u 0 equal to 30, that means when you put x equal to 0, you will get 30. Okay, so this is 30 equal to x is 0, so 0 plus b. So it is quite obvious b is 30. Okay, and then by putting 10 at x equal to 10 and this is 100, so the 100 equal to 10a plus 30. Okay, so you can simplify this. 30 will go in the left and this is 70, so a will be what? 7. Okay, that means your ux, the initial temperature distribution ux 0 is 7x plus 30. Now here you can see the temperature after getting steady states. The temperature is 20 and 40. Okay, so these 20 and 40 temperature will suggest the differential equation PDE. So the non-homogeneous differential equation is ut equal to, by using second conditions. That is after the steady state. Okay, so ut equal to c square uxx with the condition u0. Okay, so here the condition is condition will be different. So u0t is 20. Okay, and another condition is u 10 comma t equal to what? 40 degree centigrade. All other in the degree centigrade. Okay, and ux 0 equal to 7x plus 30. So it is clear this partial differential equation is non-homogeneous with the non-homogeneous boundary conditions. Okay, so the conditions are non-homogeneous. Then we change this differential equation by taking u xt equal to hx, that is the steady state solution, okay, plus v xt, and here hx is the steady state solution and v is the transient state solution. Okay, that is the time dependent solution, and this transient state solution will be 0 when t reaches to infinity. So here you can understand one thing: this temperature goes to 0 as t goes to infinity. Okay, so now this hx, okay, so first we find this hx. So hx is given by this, because you know the hx is the time independent solution. Okay, so the time independent means when you differentiate this hx here with the time t, so it will be 0. That means this part will be h double prime x equal to 0 with the condition for x only. So this is h of 0 equal to 20 and h of 10 equal to 40. These are the boundary conditions. So the similar situation is here. You can integrate twice and you will get the solution in the form of ax plus b. So let's put a small a x plus b. By using the first condition, by using h0 equal to 20, you will get easily the b is 20. Okay, and then by putting h10 equal to 40, so it will be h10 40 means this is 10 times of a plus b equal to 40. You know the b is what? B is 20, so 20 will cancel. That means directly we can write a is 2. So here the hx is 2x, hx is 2x plus 20. Okay, now the b, the transient state solution, is given by v and third stage simply bxt is given by vt equal to c square vxx with the condition v0t. Okay, so that is the homogeneous partial differential equation with the homogeneous boundary conditions as well. Okay, and v, this is 0 comma t and this is 10 comma t, that is also 0, and vx0, the initial condition vx0 equal to ux0 minus hx. So let's keep this ux0 here. So ux0 is 7x plus 30. So you can see this is 7x plus 30 and this hx is 2x minus 20. Okay, so this function is 5x plus 10 for all x lies between 10 to 0. Now by using the separation of the variable, so the separation of variable, put this equation b xt equal to capital X into capital T. Okay, and this equation will reach like t prime over t. I am writing directly. This is 1 over c squared equal to x double prime over x and equal to minus lambda square. So this minus lambda square will only work because that if you take it positive, so t will becomes infinity at t tends to infinity. Okay, so the negative lambda square will only satisfy the condition of the transient state solution. Okay, so now the boundary value problem will be x double prime plus lambda square x equal to 0 with the condition for x 0 equal to x 10 equal to 0. So these are the this is the boundary value problem, or you can say the Sturm-Liouville boundary value problem. Okay, so x equal to, so you know the solution of the x is c1 cos lambda x plus c2 sin lambda x, and by using these boundary conditions x0 equal to 0, so you will get c1 equal to 0 because this the cos 0 is 1 and sin 0 is 0. So from here we will get c1 equal to 0, and by putting x10 equal to 0, okay, so the eigenvalue from here is like sine 10 lambda. Okay, so this equation will give the eigenvalues of the boundary value problem. Okay, so this is a lambda equal to n pi over 10. So these are the eigenvalue, and the normalized eigenfunction is xnx equal to, normalized eigenfunction is sine n pi x, n pi x over 10. Okay, so this is sine n pi x over 10. So in the previous page we found eigenvalue lambda, okay, lambda n equal to n pi by 10, and the eigenfunction xn equal to sine n pi x over 10. This is the normalized eigenfunction, and for the t prime plus lambda squared c squared t equal to 0. So the normalized function for t is t n t by putting this lambda equal to e to the power negative n squared pi squared c square over 100 times of t, and then combined solution vxt, the Fourier series solution vxt equal to sigma n equal to 1 to infinity, let's say this is an exponential, or we can put this t and t and xn. Okay, so xn is sine n pi x over t. Okay, and you can see here that t and 0 is 1. Okay, so by using the initial condition vx0 equal to sigma n equal to 1 to infinity, this is an, t and 0 is 1, so this is simply sine x, the Fourier sine series. Okay, and this an will be an equal to 2 over L is 10, and integral 0 to 10 the vx0 and sine n pi x over 10 dx. By putting the vx0, I think vx0 was 10 sorry 5x plus 10, so this is 1 over 5 and integral 0 to 10 5x plus 10 times sine. So this is the definite integral, and we have to integrate by part. Okay, so by taking this is out, and the this is 5 x plus 10 is the first part, and the integral of this is minus 10 over n pi into cosine, and minus the differentiation of first will be plus, so 5 into 10 over n pi whole square, okay, and sine n pi x by 10, and the limit start from 0 to 10. So when you take the limit, okay, so 0 to 10, so the second part will be 0, okay, and the first part will give some this 10 over n pi is go out, so this is minus 2 over n pi, the bracket when you put 10, so this is 60, okay, 60 cos n pi, and minus x equal to 0, so that should be negative, x equal to 0, that means 10. Okay, so by sending this negative, or you can take this 10 is out, so the 20 over n pi, the bracket, this rest of the part is 0, so this is 1 minus 6 times minus 1 to the power n. So this is your an, then vxt is sigma n equal to 1 to infinity, this 20 over n pi, and 1 minus 6 times minus 1 to the power n, bracket close, t and t, I just write it t and t, you know the t and t is what, and sine n pi x over 10. Now you know the what is u is the vx plus x. So the uxt is the solution of non-homogeneous partial differential equation is homogeneous, steady state plus plus transient state. Okay, so the steady state solution was hx, and that was 2x plus 20. Okay, so the 2x plus 20 plus this is hx. Okay, simply you can write hx plus vxt. Okay, so hx plus vxt. So you can put the value of vxt here. So your solution will be, let me write it directly, uxt equal to 2x plus 20 plus sigma n equal to 1 to infinity, this is 20 over n pi, you can take 20 over pi is out, okay, so 1 minus 6 times minus 1 to the power n, exponential power, the value of the t and t is negative n square pi square c square, okay, negative n square pi square c square over 100 t, and the eigenfunction. So the eigenfunction is what? Sine n pi x over 10 times of x. So this is the complete solution of this partial differential equation. Thank you.